question 10, and this is a biggie, this one. Part A is okay, but part C is nasty, B is okay as well. On the axes below, sketch the graphs of these two. Nice, easy 5 marks, this. The first one, let's have a pen. Part 1, and we'll put part 2 on this graph. You have to recognise that A, it's a quadratic, because if you multiplied this out, you would get x squareds. You would actually get negative x squareds. So it's going to be an upside down parabola. It'll be that shape. So we know that. Next bit, we want to find out all the points where the curve cuts the coordinate axes. If you want to find out where any curve cuts the y-axis, so y-axis, you let x equal 0. And if x is 0 in here, you end up getting 0 multiplied by 4, which is 0. So we know that this graph cuts the y-axis at y equals 0. Now, next bit, if we want to find out all the points where it cuts the x-axis, you let y equals 0. And in most cases, with quadratics and cubics, it means you have to solve the equation. And y is 0, we need to solve this equation. It's already factorized, so we know that there's a solution when x equals 0 and x equals 4. The only way you get 0 by multiplying two things together is if one of them's 0. So either x is 0 or x equals 4. So this graph here cuts the x-axis at 0 and 4, and it's an upside down parabola. Whoop, that's it done. For the next part, it's a cubic. I'm going to just rub out this stuff here. We've already got that. And we're going to do the same again. It's a cubic, but if we multiplied out this cubic bit here, you'd get negative x cubed. Now, a positive x cubed graph goes up, down, then up. If it's negative, it goes down, up, then down. So that's going to go here. If you want to find out where it cuts the y-axis, we let x equal 0, just like before. If x is 0, we get 0 squared, which is 0, multiplied by 7, which is still 0. So this graph cuts the y-axis at 0. And we'll see where it cuts the x-axis by letting y equal 0. Right, if you're letting y equal 0, you're just solving this equation. So when you're solving this equation, when does it equal 0? There'll be a repeated root here when x is 0. So x equals 0, x equals 0. And also when x equals 7. So it crosses at 7. And because it's a repeated root, it means it's going to just touch the axes here at 0. So this sort of shape, touching there and crossing through there. Doesn't matter how high up this goes because we don't know what it is. So showing clearly the coordinates of the points where the curve crossed the coordinate axes. Done, 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 done. That's 5 easy marks. Next part. I'm sure I've got this separately somewhere. Here. Yes. Show that the x-coordinates of the points of intersection of those two graphs that we've just drawn are given by the solutions to the equation of this. And so what that's doing is it's directing you to solve these simultaneously. It just says show that the x-coordinates of the points of intersection, so whenever you're trying to find the intersection of two graphs, you do simultaneous equations. So if we attempt to try and start to solve this, we should get an equation looking like that. So for part B, if we're solving these simultaneously, just substitution, because it's y equals that and y equals that, so we can write x 4 minus x equals x squared 7 minus x. We should be able to rearrange this into this form here, and then I'm sure in the next part it asks us to solve that. Multiply everything out because there's just a common factor there, so we'll just times everything out. So we get 4x minus x squared equals 7x squared minus x cubed. I could see here that the x cubeds are positive, so I'm going to do that with mine. I'm going to take everything over at the left. So we'd have x cubed. The 7x squared would go over and become minus, so we'd have minus 8x squareds. And then just a positive 4x equals 0. and then they take out x as a common factor, which you would do if you were solving a cubic and you had a common factor of x. Oops, okay. Although I can't do that, so I'm a bit stupid. There we go, I can now. Thank you. Equals 0, and that's exactly what they've got there. X squared minus 8x plus 4 equals 0, so we've shown that. Part C, it says the point A lies on both of the curves, so it must satisfy this equation here. And the x and y coordinates of A are both positive. So if the x coordinate's positive, then this can't be the answer, this one here. X can't be 0. There are three solutions, x solutions to this one here. When x is 0, and there's another 2 solutions, which are the solutions of this, which we're going to solve in a minute. It can't be this one because it says the x coordinates are positive. So it can't be that one. So we need to look here and see if there's one positive and one negative or whatever. So we need to solve this bit here. Now it won't factorize. The reason I know it won't factorize straight away is because of the answers look at all horrible like this. There's 7 marks, so we're going to try and take our time. So we're going to try and solve this. You can solve it using the quadratic formula if you want, minus b plus or minus the square root, all that. I'm going to just complete the square because I find that quicker and takes up less space. But if you want to use the quadratic formula to get your 2 answers of x, then that's fine. So I'm going to complete the square, which is x minus 4 squared, because multiplying that out would give you x squared minus 4x, so you would get the minus 8x, but you would get plus 16. Minus 4 times minus 4, you'd get a positive 16. We just want a positive 4, so we're going to have to subtract 12. So this expression here is exactly the same as this expression here now. And now it's dead easy to solve. With anything that's written in completing the square formula, you have to take the 12 over, take this bit over. So you get left with x minus 4 all squared. You square root both sides, but remember it's plus and minus root 12. And you take the 4 over. Because it's minus 4, it'll be plus 4. So I'm just going to put the 4 first. You can see they've got something root 3. And that's because this can be simplified. Because it's root 4 times root 3, it can be 2 root 3. So there are your solutions for x. There's 2 solutions there. There's 4 plus 2 root 3 and 4 minus 2 root 3. Now it does say again, the point A lies on both of the curves and the x and y coordinates of A are both positive. So the x coordinate has to be positive. This is a positive number, 4 plus 2 root 3. 4 minus 2 root 3 is also positive, unfortunately, because 4 minus 2 root 3 is, you don't have a calculator, but root 12 is less than 4, it's 3 and a bit. And 4 take away 3 and a bit, it's going to be positive. So at the moment, we can't eliminate either one of these. It would be nice if we could, because then we could just substitute that in one of these and get the y coordinate, but at the minute we can't get rid of them. So what I'm going to do, and this is why it's 7 marks, we're going to have to do a bit more work, but I'm going to get rid of this because we don't need this anymore. We need to decide which one of these x coordinates, when we substitute it into one of these, gives us a positive y coordinate, because one of them must give us a negative y coordinate, and we can eliminate that. Oops, where did that go? We'll write that back in. 4 plus 2 root 3. So we'll just test this one first. Now you've got to substitute it, because it's an x coordinate, remember, into one of these. I think this one probably looks easier. And we'll find out what the y coordinate is. So y equals the x coordinate, which is 4 plus 2 root 3, multiplied by 4 minus, and we need to write the x coordinate again, 4 plus 2 root 3. So that is 4 plus 2 root 3, 4 minus 4, that goes. So we've just got multiplied by 2 root 3. Ooh, 4 plus 2 root 3 multiplied by 2 root 3. That's going to give us 4 lots of 2 root 3, which is 8 root 3, and then 2 root 3 times 2 root 3 is going to give us 4 and times 3, so that's 12. 4 times 2 root 3 is 8 root 3. 2 root 3 times 2 root 3 is 4 times 3, which is 12. So when x equals 4 plus 2 root 3, y equals 8 root 3 plus 12. Now they are both positive, so they must be the solutions. I suppose I better show why this one must fall apart. You must get a negative y coordinate for this one. So these are our final answers. It says find the exact coordinates of A, leaving your answer in the form blah, 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 blah. So I'm going to do that now, and then we'll maybe I'll show you that if we pick the other one, you must get a negative answer for the y coordinate, because we can't have two answers. So x equals, so the coordinates for the final bit is 4 plus 2 root 3, comma, and I'll write it in that form with the number bit first. So that's the final answer. That's the pair of coordinates, all done and dusted there. But I just want to, for the sake of arguments, see what would have happened if we'd picked the other one. So if we'd picked this one here, right, this is, you don't really have to do this because we've found x and y that are both positive. We were lucky that we picked this one first. If we'd picked x equal in this, let's substitute it in here and see what happens. Y equals x, which is 4 minus 2 root 3, multiplied by 4, subtract 4 minus 2 root 3. That goes, so y equals 4 minus 2 root 3, all multiplied by minus 2 root 3. And when we multiply that out, you get 4 multiplying this, which would give you negative 8 root 3. And then you get 2 root 3 negative times 2 root 3 negative, which gives you positive 12. And if you work out 12 take away 8 root 3, that must be a negative number, although only just. The reason why I can see that's negative is because in this form, root 3 is 1 and a bit, and it's hard to work out if that's going to be negative. But negative 8 root 3 is the same as negative 64 times 3, which is 192. Negative 8 root 3 is the same as negative 192. And because 13 times 13 is 169, and 14 times 14 is 196, I know that this is roughly negative 13 point something. So 12 take away 13 point something could give you a negative. But so when it doesn't satisfy this bit here because it says the x and y coordinates of A are both positive. So if we'd picked this one first, yes, the x coordinate is positive, 4 minus 2 root 3, but the y coordinate, when you substitute it into one of these, the y coordinate works out at being negative 13 and a bit plus 12, which gives you negative 1 and a bit or something like that. So it's just negative, so that doesn't work. So that was just for argument's sake. But if you pick this one like I did first time round and you got positive x, positive y, then that's it, finished. So final answer, x coordinate 4 plus 2 root 3, y coordinate 12 plus 8 root 3. Whew.